So if we look at the data that's in front of us, how might we describe what you see here in this graph? What sort of form is it presented as?
Form of a graph, scatter plot.
How do you know it's a scatter plot?
Because there is a plots and RV and EV, two variables.
Okay, so two variables here, two types of data, and what type of data is being graphed here?
Weight and glucose level.
And they are numerical variables.
Numerical values, yeah.
How do you know that they're numerical variables?
Because we can't order them, so we can't say they are categorical.
And
Or
measure them.
Yeah, we can measure them. So we say weight, it's measured in kilogram. So we say it's numerical.
Okay, so we measure both
Yep,
blood
and glucose
glucose
level as well.
and
Numerical
weight.
discrete.
And if we look at this first question, it asks which one's going to be the RV or the response variable and which one's going to be the EV or the explanatory variable. Which one would you choose as the response?
The glucose level.
And why would you do that?
Because we can explain the glucose level by predicting the weight. No, predicting the glucose level by the weight. We can predict, but we can't do it the other way around.
Why wouldn't it be right the other way around? Can you give me a sentence what it would sound like?
Because the glucose level is depending on the weight. So
Yeah.
weight is changing the glucose level. So it's dependent on the weight.
So if a person have a high body weight, he will have a high level of glucose.
Oh, thank you. And if we look at this scatter plot, how might you use the words that we've developed to describe these scatter plots? What word might you use to describe it?
Strong or weak. We look at the R, correlation coefficient.
And if we didn't know the R, what might we do with this graph here to figure out its association between...
We look at the dot points, if they are strongly pushed together, so there is strong association between them. However, it seems like a moderate. So
Okay, when you use that term push together, can we
Compressed.
use another word to shift it up our register continuum a little bit?
Compressed.
Compressed. So we would want to see the points compressed closer together.
Yeah.
And if we downshifted it, what was the word that you described?
Stretch.
Stretched. So we can use different words to describe this association.
yeah.
Yeah.
So let's imagine we had an R squared of 0.75. What word might we use to describe the association?
Strong.
Moderated.
Strong. 7.5.
7.5.
Yep.
Yeah. Positive.
Positive?
Strong
Close to
association.
7.4.
Okay, so can we put this in a sentence like we might be describing it in
Yeah.
an
Yep.
assessment task?
Yeah.
There is strong association between the glucose level and the weight.
Great, thank you.
Strong positive association.
Okay, and why do we say it's positive?
Because it's
Increasing
it's
as the
increasing trend.
Okay, and if we didn't use that word increasing and we changed on our register continuum, what word might we use to describe this graph instead of increasing?
Growth going up.
Growth, yep, and going up.
Yeah.
And is there another word we might use?
high body weight,
High body weight leads to...
High
High
glucose level.
glucose level.
Okay, so we can describe this association using everyday
Different
language,
Yeah.
or we can shift it to the technical
Register
register.
continuum. Yeah.
Exactly. Thank you. If we look at the regression plot, how might we describe this regression plot?
If the points, the plots are randomly, or there is no pattern between them,
Yep, and there's
and
one...
there is outlier
Okay, how do you know it's an outlier?
because it's far away from the dots.
The other data points.
Yeah, it's excluded from the other point.
Okay, so we're using some technical language here. What was the technical language that you used?
excluded.
Excluded, and if we shift that down into everyday spoken, you use the term...
Far away.
Far away. So we can see in a SAC response, we'd use the term
Excluded.
excluded. Great.